Hey there, math hoppers! In this video lesson, we will solve linear systems of equations with inverse matrices. So let's consider this linear system. It has two linear equations. Remember that the solution to this system would simply be the intersection of these two equations. And if I want to solve it with a matrix equation, I simply have to transform this linear system into a matrix equation, which is surprisingly very easy to do. So when we transform it, the matrix equation will have three parts. It will have the coefficient matrix, which will be made up of the coefficients of x and y in the top and bottom equation. We'll multiply that to the variable matrix, which will have x and y, because those are our variables in this system. And we'll set it equal to the solution matrix. Solution matrix will consist of 16 and 8, because that's the solution to each of the equations. So let's go ahead and make that right now. So our coefficient matrix looks like this. First row is 1, 4, simply because the coefficient of x and y in that first or top equation is 1 and 4. Bottom row is 3 and 4 for the same reason. Coefficient of x and y in the bottom equation is 3 and 4. Multiply it to the variable matrix. The variable matrix will be listed as x on top, y on bottom. Always it will be in this order. If we had three equations, it would be x, then y, then z at the very bottom. We will set that equal to the solution matrix. Solution matrix will have 16 on top because it's the solution to the top equation, and 8 on bottom because it's the solution to the bottom equation. Okay, so let's label everything. We are going to call the coefficient matrix, matrix A. The variable matrix will actually be the variable in our equation, so we'll call that x. And then the solution matrix will be matrix B, or we'll just call it B. So there we have it. We'll have A times x equals b. So this is a very simple linear system, or linear equation, or at least it looks like one. It takes the form a times x equals b. Now I realize a and b are matrices, so this is not just a very simple linear equation, but pretend it was. If we had a linear equation 2 times x equals 4, we would simply divide both sides by 2 to solve for x. Now with matrices, we do not divide matrices. So what we have to do instead is, instead of dividing by A, we have to multiply by the inverse of A. So that inverse matrix, we're going to multiply, and technically we'll multiply by both sides. Multiply A by its inverse, you get the identity matrix, which is equal to 1, and then you'll multiply the inverse of A times B. But really, we're not going to show both sides multiplication. We're simply going to state the solution matrix X is given by the inverse of A times B. Okay? Now, remember, why are we multiplying by an inverse? Because we do not divide matrices. So we have to multiply by that inverse matrix. We'll multiply by the inverse matrix, the inverse of the matrix multiplied to x, instead of dividing. Okay? And now, when we say x is equal to the inverse of A times B, this order is very important. Remember that matrix multiplication is not commutative. So we have to multiply in that order. The inverse of A times B. All right, let's get to solving this. So we have our matrix equation. Remember that we have AX equals B. The solution matrix is given by the inverse of A times B. So let's look at what we have. We have matrix A times the variable matrix equals matrix B. That's where we get the AX equals B. So now, in order to solve this, we need to find or calculate the inverse of A. So let's review how to find the inverse of a square 2 by 2 matrix. Remember, this is the easy matrix to calculate an inverse for. So given matrix A, where you have A, B, C, D as the entries, you are going to find the inverse by doing 1 divided by AD minus BC. So remember, we're going to take A times D and subtract from that C times B. And then we're going to multiply this by the reloaded matrix, or the matrix reloaded, as I like to call it, where A and D are going to switch positions and B and C are going to switch signs. Remember that this AD minus BC has a fancy name. It is called the determinant of the matrix. It is called the determinant because it determines if an inverse exists. Notice that AD minus BC is in the denominator of a fraction. So if that value, if the determinant is 0, then no inverse matrix exists, because remember, we cannot divide by 0. So in your textbooks, the rule for the inverse of a square 2 by 2 matrix is likely given by this: 1 over the determinant times this matrix reloaded, where D and A switch places and B and C switch signs. So let's go ahead and solve for that determinant. AD minus BC. How are we going to do that? AD is going to be 1 times 4. So we will have 1 times 4 minus B times C. What's B times C? B times C, as we can see, is 4 times 3. So 1 times 4 minus 4 times 3 is 4 minus 12, which gives us a negative 8. Perfect. We are going to take 1 over negative 8, multiply it by the matrix reloaded. So what did I do here? A and D switch places. See how 1 and 4 switch places? It's 4 and 1. And 4 and 3 here switched signs. Now, technically, we could leave it like this. But we're going to take it a step further and multiply every entry by negative 1/8. When we do that, 4 times negative 1/8 is negative 1/2. Negative 4 times a negative 1/8 will be positive 1/2. Then we get 3/8 down here. Remember, negative times negative. And we get negative 1/8 here in the bottom right. Okay, so what does this give us? This gives us the inverse of A. And we know that we have to take that and multiply it by B to solve for this system. So all we have to do now is multiply 2 matrices. And we need a new page because we've run out of room. All right, so there we have it. X is equal to the inverse of A times B. We have the inverse of A. We have always had B. Let's multiply them. Remember, when we multiply matrices, we look at the dimensions of the matrices. If the inner dimensions are the same, we can multiply them. 2 and 2 are the same, so we can. The outer dimensions are the dimensions of our product. So the dimensions of our product are 2 by 1. So let's make a shell matrix, a 2 by 1 shell matrix. And when we do that, it looks like this. We have 2 rows, 1 column. All right, so to get that top position, you're going to take the top row times the only column. So negative 1/2 times 16 is going to be negative 8. And then you're going to take 1/2 times 8. 1/2 times 8 is 4, and you're going to add those values. So negative 8 plus 4 is negative 4. Negative 4 is our top entry. Remember, that's what X equals. All right, let's solve for the bottom entry. The bottom entry, we're going to take bottom row, only column. 3/8 times 16. I know you're thinking, I don't want to multiply 3/8, but don't worry. 8 divides into 16 twice, and 2 times 3 is 6, so that's easy. That's 6. And then negative 1/8 times 8 is simply negative 1. So we get 6 plus negative 1, or 5. All right, those are our solutions. Let's write them as a matrix, right? This is our new or solution matrix, where we have negative 4 on top, 5 on bottom. Let's remind ourselves what that equals or what it represents. Negative 4 is our X value. 5 is our Y value. Let's not forget to check. Let's just throw it into the main equation. Remember, we had X plus 4 or negative X plus 4. No, we had X plus 4Y equals 16. So negative 4 plus 20 equals 16, and it does. Right? And then we had 3X plus 4Y equals 8. So 3 times negative 4 is negative 12. 4 times 5 is 20. Negative 12 plus 20 is 8. So our answer does check. Let's just really quickly review the steps we went through. So if you are going to take a linear system and you are going to solve it with a matrix equation, your first step is to transform it into a matrix equation in the form AX equals B. So the coefficient matrix times the variable matrix equals the solution matrix. Then you'll have to take matrix A and solve for the inverse of A. And then you'll multiply both sides of the equation by that. And really, we're just going to multiply the inverse of A times B. That will give us our solution matrix. Remember, we're not really multiplying both sides, but it's implied that we did. All right, still have questions? You should be subscribed to our YouTube channel. You send those questions to me, and I'll make you a custom video solution. Till next time, Math Hoppers, take it easy.